Welcome viewers to another video brought to you by K.Creative's Academy. I am your tutor, Mr. Kaira, and in this video we will look at organic chemistry. We will answer past paper questions based on organic chemistry, and the questions we'll be answering in this video are the questions that came in the 2023 internal exam paper 2023. Okay, so the the question before us is, this is how the question came on organic chemistry. It was on question 9, section B. Alkanes form a homologous series of organic compounds which are also called paraffins. Okay, and 9A reads Roman numeral 1. State the general molecular formula to which the alkanes conform. Okay, then question 2, draw the displayed structural formula of pentane. Question B, give 2 reasons why cracking of large hydrocarbons is important. Okay, then question C says justify why alkanes are sometimes called paraffins. Okay, so this was the question. This is how the question came. So let me first remind you on what they mean by homologous series. So the homologous series, they are just basically groups. Okay, they are groups of organic compounds, okay, of which the first group we've been given here are the alkanes. Okay, the alkanes is one of the groups of organic compounds, and what you will notice in this group is that the compounds that are found in this group, they end with ane. Okay, they end with ane. That is singular. Okay, and then plural, they will just have an s there, like that. Okay, so an example of these compounds, we are talking of compounds like ethane. Okay, have you seen the ane? Hope it's clear. The other examples include methane, propane, butane, etc., etc. Okay, the other homologous group that you will notice, that you will find in organic chemistry, are the alkenes. Okay, these are different from the alkanes in the sense that the alkenes, their suffix, okay, the suffix is ene. Okay, that is singular. Plural, you just add an s as well. Okay, that is the difference. Meaning that the compounds that fall under alkenes, they all end with the ene. Okay, they end with that suffix. So for alkenes, there is no there is no ethene. It starts from methane. Okay, so you have compounds like methane. Okay, have you seen that suffix ene? Okay, there will also be propane, butane, etc., etc. There is also another group which we call the alcohols. Okay, equally this one ends with the suffix ol. Okay, ol. So you expect compounds in here to be ending with the ol. For example, ethanol. Okay, methanol. Okay, ethanol, like that suffix. Okay, yeah. And also the list goes on. There's also the carboxylic acid. Okay, the carboxylic acid, which ends with the anoic. Okay, which ends with the suffix anoic. Okay, so you expect to find compounds like methanoic acid. Okay, butanoic acid, ethanoic acid, stuff like that. Okay, so the homologous group we've been given in here in this question are the alkanes. These are the ones that we will be looking at today. So states the general molecular formula to which the alkanes conform. Okay, so the answer for A1, okay, was this one. So this is the general molecular formula. Okay, as you can see in the question. So you should know that each homologous group has its chemical formula, okay, its general chemical formula to which the compounds, okay, to which these compounds conform. Okay, conform it's basically being formed. Okay, the general molecular formula is what determines how many carbons the compound will have, and how many hydrogens it will have. So this one is specifically for this one is specifically for the alkanes. Okay, so the n there, the n represents the number of number of sorry n n basically denotes a whole number. Okay, a whole number, and it's also the number of the carbons. Okay, so what we mean by whole number is the whole number can either be 1, okay, 2, 3, and the list and the list goes on. Okay, yeah, so uh, this is how it works. Okay, this is how we use the general molecular formula. I will give an example of so let's look at an example of methane. Okay, by the way, the compounds in each homologous series are arranged in the according in the order according to the number of carbons that the compound has. Okay, for example, the methane this uh, this myth. Okay, myth means one. Okay, it means one, meaning that in this methane the number of carbon atoms which I need is one. Okay, and this is the number will be represented by n. Okay, so to draw the structure of methane, looking at what we have. So if n is equal to 1, if we substitute this one in the molecular formula wherever there is n, so what we'll have is we will end up with c with a 1, okay, of which the one we don't show. Then we'll have h. So there on n, if we put 1 there, it will be 1 times 2, which will be 2, and 2 plus 2, it will be 4. So meaning our compound will be CH4. Okay, and this is how the structure we will look at in case we are asked to draw. Okay, so it will have 4 hydrogens bound to one atom to one atom of carbon. Okay, as you can see, the hydrogens 1, 2, 3, 4. Okay, um, so another example is ethane. Okay, this is the next compound after methane. Okay, so this, since it comes second on the list, this means that the number of the carbon atoms which it has is 2. Okay, and this is the number which which n will represent. Okay, and this is how the molecular structure will be. So there we'll have n, we'll have carbon on n we'll substitute 2. Okay, because here we're saying that N is equal to 2. So if we put 2 there, then followed by hydrogen, which is 2, then this multiplied by 2 plus 2. That's according to the general formula. So here, if we work out the calculations, we'll find that our carbon will have 2 atoms of carbon. Then H here, if we say 2 times 2, that will be 2 times 2 there, that will be 4. Okay, then 4 plus 2, that will be 6. Okay, meaning that the hydrogens will be 6 in this structure. Okay, and if we were to draw this structure, this molecular structure, we will remember what we're having is a C2H6. So the structure will look like this. We will start first by drawing the carbons and bonding them, okay, with just a single bond in between them. Then the carbon, the hydrogens will bond there. Okay, so 1, 2, 3, 4, 5, and 6. Okay, that's how the structure will look like. So if the compound is having more than one carbon, ensure that the carbon to carbon bonds is shown. Okay, you join the carbon to its carbon. Okay, so this is how the general molecular formula works. Okay, uh, the next compound which we can work out also in our free times is propane. Okay, propane, meaning that since it comes dead, the number of carbon atoms it has 3. Okay, and the list goes on where butane comes fourth, pentane comes fifth, and the likes. So what you will notice on in the compounds I was using as examples, remember we are in the homologous series of alkanes. Okay, alkanes. All the compounds I listed, they were ending with the suffix ane. Okay, ane. So it is important that you know the general molecular formula for each homologous series. Okay, so this one is specifically for the alkanes. For the sake of revision, the general molecular formula for the alkenes. Okay, I'm now talking about the alkenes. Okay, the alkenes is Cn. Okay, H2n, just like that. The only difference between the one for the alkanes and the alkenes is that the alkenes, you don't add a 2 as in the alkanes. Okay, yes. And when you want to know the structure, the structure is you use the general molecular formula the same way we were using on the alkenes. Okay, then there's also for the alcohols. So for the alcohols, okay, so that's for the that's for the alcohols, the general molecular formula for the alcohols. Okay, you do the same thing where n depending on the position of the compound determines the number of the carbons, and that number is what you will use to put on n wherever there is n. Okay, and then to that group attach the OH. Okay, same with the carboxylic acids. So for the carboxylic acid, the general formula, the general molecular formula is CnH2n plus 1, except for this one we had a Q to it. Okay, Q. Okay, so so That was the answer for A Roman numeral 1. Let's see what we're having in question 2. So question 2 says, draw the displayed structural formula of pentane. Draw the displayed structural formula of pentane. Okay, so we will do this one from that spacing. Okay, so remember the general molecular formula. So the general molecular formula for the alkanes is that one. Okay, that's what we will use to to know the structure which we are having. Okay, so the structure, okay, the structure that we are having, pentane. So pentane on the list of the compounds, you find it on position 5. Okay, penta means 5, meaning that the carbon structures it's having, mean the carbon atoms are 5. Okay, yeah, so that 5 is what we will represent n. Okay, so we will say on n there we'll say 5. Remember, n is equal to 5. 5, then h2 multiplied by 5, then plus 2. Okay, of which the structure will end up with is h 2 times 5, that's 10, plus 2, that's 12. So that is the structure of pentane. Okay, so we will draw that structure. Okay, so that's 5h12. Okay, so this is how the structure will look like. So we start with the carbon atoms. Make sure they are 5. So 1, 2, 3, 4, 5. Okay, hope the space allows. Okay, then we will join the carbon, the hydrogen atoms on the remaining spaces. So H there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the structure of pentane. Okay, remember, ensure that the bonds are joined. Okay, then question 6 says, give 2 reasons why cracking of large hydrocarbons is important. So the importance, okay, the first importance of cracking the large hydrocarbons is in order to meet the economical demand of various fractions of crude oil, such as gasoline. Sorry about the spelling. It's supposed to be gasoline. Okay, gasoline, benzene, uh, benzene and diesel, etc., etc. Okay, these organic compounds can sometimes be, they are usually of large hydrocarbons. So by cracking them, you reduce them to various fractions which are used in industries by various machines. Okay, for example, petrol engine vehicles, they use petrol. Diesel engine vehicles, those use diesel, etc., etc. Then another importance is for the production of raw material for petrochemical industries, used in the production of synthetic compounds like plastics. Okay, plastics, other substances like rubber. Okay, okay, then question C. Justify why alkanes are sometimes called paraffins. Okay, so the reason why alkanes are sometimes called paraffins, it is because So alkanes are sometimes called paraffins simply because they barely react with the other elements or compounds. Okay, with other elements or compounds. With the exception, okay, so under normal conditions, okay, under normal conditions, alkanes, which are basically paraffins, they barely react with these other substances, okay. And the reason is because the alkanes have saturated hydrocarbons between them, meaning that between the carbon to carbon bonds, there's just a single bond, okay, and the rest of the bonding is occupied by the hydrogens, okay. This is one thing you will notice about the structures of the alkanes, okay. Between between the carbon to carbon bond, there is only a single bond. So this is what makes them barely or less reactive, okay. They would have been reactive if at all in between the carbon atoms they had double bonds like that, which would mean that these structures would be free, and the structure now becomes it will now fall under the homologous group of the alkenes, okay. The alkenes, and this is the characteristic of alkenes. Alkenes have double bonds between the carbon to carbon atoms, okay. So otherwise because of the single bonds between the carbon to carbon, this alkane that doesn't have room for other substances to bind that, although there is an exception, okay. There is an exception here, with the exception of halogens and oxygen. So alkanes, even though they are less reactive, they still react with oxygen, okay, with oxygen to undergo a combustion process. And the reaction, we call it a complete combustion. So the alkanes react with oxygen to produce carbon dioxide and water, and also they undergo a substitution reaction with the halogens, okay, with the halogens, which the halogens, they substitute the hydrogen atoms, okay. Yeah. Otherwise, this is where we'll end in our first part of organic chemistry. Thank you all for tuning in. Don't forget to like and subscribe to my channel so that you don't miss out. Shalom, shalom.